Hello everyone, this is our group video presentation for subject PHY210. So in this assignment, we require to propose an innovative idea for entrepreneurship based on rotational mechanics and thermophysics. My name is Hanan Afifah binti Azisham and my student ID is 2024680078.
Hello, my name is Fakira Fazana binti Muhammad Hafizun and my student ID 2024227622.
Hey everyone, my name is Ainu Imanaja Akira binti Asman and my student ID is 2024-22523.
Hello, my name is Zaira Natasha binti Muhammad Zahid. My student ID is 20246968874.
The product that we invented are Smart Insulated Lunchbox Thermobox Pro. First thing first, I'm going to explain about what is meant by thermophysics. Thermophysics is the branch of physics that deals with the relationship between temperature and heat. So what is temperature? Temperature is a measure of average kinetic energy of individual molecule, either hot or even cold. What about heat? What is heat? Heat is the energy transfer between one object to another object because of the difference in temperature. So let's move on to the next term, which is specific heat capacity. So what is specific heat capacity? Specific heat capacity is the amount of heat needed to rise the temperature of 1 kg molecule by 1 degree Celsius. The formula of heat capacity are C equal to Q, which is the heat energy, divided with the mass and also the difference of the temperature. Calorimetry is the measuring the amount of heat transfer to or from a substance during physical or chemical. So what is an isolated system? Isolated system is the closed system which no energy in any form is transferred. So isolated system means Q loss equal to Q gain. Since our product are the lunchbox, which means we keep the food inside the lunchbox to keep it warm or cold, so means there are no energy transfer in or out of the lunchbox. So the isolated system term are being used. So you must be wondering, how does the product relate to the concept from PHY210 chapter 4? So the innovation of this product uses firstly heat transfer prevention. It uses thermal insulation such as conduction, convection and also radiation. So conduction is by using material like foam or vacuum layers to make the lunchbox because it have low thermal conductivity. Secondly, we have convection. Convection is by sealing the container to prevent air movement. And lastly, we have radiation. Some lunchbox have reflective inner surfaces to reflect heat back into the food to keep the food warm inside the lunchbox. Secondly, we have thermal equilibrium. So the innovation of this product delays the thermal equilibrium between the hot food and the cool surrounding. So let's move on to the next one, which is specific heat capacity. Food with high specific heat, like soup or even rice, retain heat longer. Next one, we have pace change. Items that come together with the lunchbox, such as gel pipes that undergo pace changes, melting and freezing, is to absorb and release heat, helping to maintain temperature inside the lunchbox. Lastly, we have material science. Materials are chosen based on their thermal conductivity. One of the best material that we can use to make a lunchbox is stainless steel inner lining.
So for this slide, I will talk about the product components and its function. On the left side, we have the example picture of the product that is a smart thermal lunchbox. For the right side is the picture from the inside thermal lunchbox that show the detail of the components. To be stated, there is heating element, control panel, temperature sensor, battery, and insulation. And for this slide, it shows the detailed picture of the components that show view from above. There is heating element, temperature sensor, battery, food chamber, high quality insulation material, control panel, and control launcher. Component and function. This slide states about each component and its function. For starter, heating elements generate heat to warm up or maintain the temperature of the food inside the lunchbox. Temperature sensor. The sensor accurately monitors the current temperature of the food within the lunchbox along with feedback to control system to ensure the desired temperature maintained. Food chamber. Compartment of the food is designed to be food safe and often removable for easy cleaning. Next. Battery. Provide necessary power to operate the heating element, the control panel, and any electronic components. Is typically rechargeable. Insulation. The material often a foam or vacuum layer that surrounds the food compartment to minimize heat transfer in and out and maintain the food temperature for extended period. And lastly, control panel, the user interface of the lunchbox that includes buttons and display screen or connect with apps to let the user adjust the temperature, set the time, and control other functions. How, when, and benefits of the thermal lunchbox. For how, activate the heating function via control panel or connect apps to use before lunch hour. For when, hot meals, when you want to enjoy a warm home-cooked meal without relying on microwave or cafeteria. For cold meals, for cool and fresh meal like salads, fruits, or sandwiches. There is also benefits of the thermal lunchbox. There's 3 of them. First, can maintain both hot and cold temperature. Second, save cost from buying unhealthy roadside food. And the third, designed for convenience to bring anywhere.
Okay, so now let's move on to the component of need. For the first question, what key need will you need? So our product aims to maintain food temperature either hot or cool for several hours after being packed. Many people prepare their meals early in the morning but only consume them during lunchtime or later in the day. Without proper insulation, the food lost its original temperature and become less appetizing or even unsafe to eat. This project addressed that need by introducing a thermal insulated lunchbox that applies physics principle to preserve the food's temperature more effectively. Second one, Whose key need? Specifically, this is experienced by a wide range of users in daily life. So first, student with long class schedule. Second, parents preparing food for children. And the third one is a food delivery riders and small F&B business. Imagine students packing food at 6:30 a.m. but only eat at 12 p.m. Without proper insulation, the food becomes cold by lunchtime, reducing both its taste and nutrient quality. Next, how often do people experience this problem and when? This is a daily problem, especially during school or workday. Every morning, thousands of students and workers prepare food to take with them. However, most do not consume it immediately. They eat a few hours later. There are several common experiences. First, long lecture or meeting. Second one, no access to reheating facility. And the last one is long commutes or early packing times. Next question, how big is the problem for users or customers? The impact of this problem is significant, both financial and in terms of convenience. When food becomes cool, soggy or spoiled, it is either unpleasant to eat or has to be thrown away, resulting in food waste. Users may also need to buy replacement food from outside, leading to unplanned daily expense. For example, students and workers who pack lunch to save money may end up spending maybe 6 to 50 ringgit per meal if they discard their home packed food. Over time, this extra spending adds up and defeats the original purpose of packing food. Additional, throwing away uneaten food contribute to environmental waste. In the case of children or patients, spoiled food may even pose health risks. Therefore, no solving this problem can result in waste money, reduced food quality, and negative health or environmental effect. The last question, what will happen if the need is not met? If this need is not addressed, people may lose motivation to bring meals from home together. They may choose to buy food outside more frequently, which is often more expensive and may not meet their dietary or hygiene preference. This can lead to increased spending, unhealthy eating habit, and greater reliance on disposable packaging, contributing to environmental pollution. For students or individuals with strict dietary needs, the inability to maintain food quality can also lead to missed meals or poor nutrition. In short, failure to meet this need will negatively affect health, daily routine, financial planning, and overall user satisfaction. That is why a well-designed, thermal-efficient lunchbox is not just a convenient, it is a necessary.
Moving on to the next slide, which is component of approach. To make our product truly stand out, we have designed it with a unique approach. Firstly, it has double layer. The inner part was made of stainless steel and the outer part has a plastic coat that has cute and glossy appearance to attract buyers to buy our product. Secondly, it is removable and easy to clean. You can take it apart easily, making cleaning faster and more hygienic. It also includes an extra bowl for storing different types of food. Lastly, our product is eco-friendly. We use biodegradable materials to reduce environmental impact. Our product solves three major problems. Firstly, it is compact design, make it easy to carry anywhere, anytime without any hassle. Secondly, it comes at an affordable price, which is a great value for our target buyers. Finally, we also installed an airtight sealing lid to prevent leakage. No more messy bags in the morning. Of course, every innovation comes with challenges. We have identified 3 technical issues to address. 1. Serious leakage issue. We are solving this by using a stronger silicone gasket to keep it fully sealed in your bag. The next one is uneven heat loss. While the lid is leak-proof, we also ensure that it is easy to open it without any struggle. And lastly, there's odor retention and staining. We are using stainless steel inner coating that resists both odor and staining to keep the food fresh and the product clean.